Alright, so in this video I'll be talking, this is a Calc 3 video, I think 3 or 4. Basically in this video I'm going to be talking about vector multiplication, or one of the ways you can multiply vectors. And basically vector multiplication, there are two ways to do it. There's a dot product version, which is basically you take two vectors and you multiply them, and the result you get is a scalar. And basically, which just has magnitude, like temperature would be a scalar, in case I didn't mention that in the previous video. Basically, and then the cross product, which I'll get into the next video, is where you take two vectors and then you multiply them, and the result you get is a vector. And it's really a pseudo vector. That's just a terminology. Basically, so we're just going to get right into some basic what the dot product really is all about. But one concept that I did not really talk about too much is in the previous videos was scaling a vector, and really that's a very straightforward thing to do. Here I have vector A, and it's just like I said, an arrow, and so here I wrote CA, and basically C is any real number which scales A, and basically what that does is you have a vector about this long, and if C is greater than 1, the vector becomes longer, if it's less than 1, it shrinks. And so I kind of just drew a longer arrow to illustrate that. If C is greater than 1, the vector increases. If C is less than 1, the vector shrinks, and it kind of makes sense because if you multiply by a fraction, your original quantity gets smaller. And so let's just do like a little bit of a review of everything we know about vectors so far. So we have vector A, 3, -2, 4, and vector B, -4, 0, 2. And again, these are just random numbers I came up with off the top of my head. And so let's say we want to do 3a minus b, and so the way you do that is first you scale a by 3, and so basically every component here gets multiplied by this scalar out here. So we get 9, -6, and 12. And so well, I'll probably just do this in 2 steps. So I'm just going to go erase this for now. I'm going to do this. I'm going to write it all out just so you can see exactly what I'm doing. I don't want to just do it all in my head just because I know how to do it. It's not really helpful for people who are just learning it for the first time. So basically, so we get 3 times 3, and then we have -2 times 3, and then we have 4 times 3, and so here we're going to get 9. Here we're going to get -6, and here we're going to get 12. And from that we subtract b. And so remember what I said, that subtracting vectors is the same thing as adding a negative. But really, when you're doing these, you don't really have to go through all of that. You can simply just subtract it. So basically now for the minus b part, we have -4. So it becomes +4, and so we're going to get 13. And here it just becomes a -6 because it's a 0 here. Nothing changes. And then we have 2 over here. So this becomes 10. So our entire vector, 3a minus b, we get 13, -6, and 10. And remember that this can also be written as 13i minus 6j plus 10k for the unit vector notation. And basically, so when you're doing the multiplication, just make sure that you're kind of if you can practice them a few times, then you can probably do them in your head. But really, it's kind of a straightforward process, just scaling vectors and adding and subtracting them. Kind of, it's not too bad. And now, so basically, when you want to multiply two vectors rather than just add or subtract them, that's given by the dot product. As I said, when you it's one way to multiply them. So you write this really as a dot b, and really a dot b is kind of like what we're doing with addition. For when you have the vectors in component form, you essentially just multiply all the components, kind of like what you were doing with adding. So, but basically here it's a little different because remember the output is a scalar, so you're not going to get a vector result. And I'll just do a problem. So basically here you're going to have 3 times -4, and then you're going to have plus -2 times 0 plus 2 times 4. And basically here, so here you're going to get -12. This is 0, so that term just that term dies. And here you're going to get 8. Yeah, 8. So and then the result is just -4. That's the answer, because like I said, dot product, your output's a scalar. So what you do is you simply just take the components of vector A, and that's not where I should be pointing. This component multiplied by this component, and then this plus this component by this component plus this component this component. So really, if you have like n-dimensional vector, which you can just multiply all the components and just kind of add them as you go along. It's pretty straightforward. And so basically, this is what happens when you have the dot product with components. Alternatively, you can have this over here. You have more of a geometric way of doing it. And here I've drawn, maybe this notation is a little unfamiliar to people who are doing this for the first time. Basically, these double brackets, these bars, they mean Euclidean norm, which is, essentially, really what that is. I'm just going to write it out. Basically, it means vector magnitude. Euclidean norm is a more fancy term, but basically, so here you have a vector A, the magnitude, and that's really just given by the square root of ax squared, which is the x component of the vector, plus ay squared, which is the y component of the vector, and then you have, since it's three-dimensional, plus az squared. So really, if you wanted to do the dot product in geometric terms, usually it's like when they're in physics, if you take in physics, the concept of work, which is, you have essentially, like, let's say you have like a box right here, and then this just, random box, and so basically, you have a force. Let's say we have we'll have a force going this way, just like that. And so let's say that you're pushing on the block, just random person, let's call him, Dave or whatever. So Dave's pushing on this, and then make sure to do that. And so basically, dot product is useful for calculating how work is done. Basically, let's say that if you're working these problems, sometimes they're going to give you how much force is applied to the box and how far it was moved. And so basically those can be your two vectors here, and you basically just break it up into the components, and then you take the angle between them. And so it's important to note, so when you have two vectors, like here, if he's pushing, there's really only one vector here. This is probably not really the best example, but I'm just going to continue with it anyways. So basically here, let's just say that this is like, x equals 0, and then this is like, how far he pushes it. Now here, the cosine cosine of 0 is 1, and so that's important to know, because if the force was going up, like if we had another situation, let's put it over here, and so if you were pushing up, no work is done in this direction. Like here, nothing is done because the cosine of 1 is 0. So you can think of it geometrically. And so really, if we had like a different example, let's say we have like two vectors like this, kind of like this. And so, and if you knew how let's say this vector's like what, 11, magnitude's 11, and then so and then this magnitude is like I guess call it 12. And of course, you need to break this up into components, which I will get into in a second. So you have that vector, and it has an x and a y component. So this would be like, a vector ay. This is a vector, well, not really a vector, it's components. And so the way you do it is you simply just do so we can break up the components by doing it this way. You can have ax times the magnitude of a times the cosine of theta, and then if you want the y component, it's magnitude times sine of theta. That's the standard way to do it. Of course, if you choose your coordinate system a certain way, then you won't be able to. Then you have to switch. You have to make sure you're getting the right angle. But typically, it's this angle right here. If you have two vectors and you want to find the dot product, you find the angle between them. That's the one that's important. So that pretty much is what the dot product is all about. It's really just a recap. I kind of threw a lot of stuff out there. Basically, for the unit vector part, it's pretty straightforward. Just multiply all the components, add them together, make sure your result is scalar. That's important to note. And when you do the dot product in a geometric way, you're given two vectors and you want to compute the magnitude of them. So you basically just take all the components and just kind of do like the Pythagorean theorem, and then multiply them, and then you times vector b and times the angle between them, and that will be the dot product of the two vectors. And kind of like an application of physics would be, when you're pushing on a box, the force you apply, and of course how far you move it. That is very important. And of course, you can have something more complicated, like if you had like a force going like this. This is like, call it force 2, whatever. That would be obviously different amount of work done than here. So you would be doing more work this way, because here you have some y component, going. But anyway, that's physics. So the way you break up a vector into components, you have ax times the magnitude. Ax is equal to the magnitude times the cosine of theta, and then the y component is equal to the magnitude times sine of theta. And sometimes you're going to need to break the vectors into components in order to solve some problems. And so that pretty much is an overview of the dot product, and the next video I'll be talking about the cross product. So it's a good stopping point. I'll see you guys in the next video.